Hi, this is part 5 of the introduction to Tellurium. In this part, we're going to talk about plotting. And we previously saw that if you had a Roadrunner object and you did some simulations with it, you could do r.plot and you would plot the data. Now, that's great for simple plots and you'll use that a lot. But if you want to do a bit more, something a little bit more sophisticated, you need to use the matplotlib library directly. So let's have a look at that, shall we? So in order to use the matplotlib library, which is the main plotting library for Python, we have to import this rather long-looking import statement. So it's import matplotlib.pyplot as plut. That's a standard way of importing matplotlib, and we'll be generally using PLT then as the package name. Okay, so the other thing I'm going to do is I'm going to import NumPy, which is the array package for Python. I'm not going to say too much about that, but I'm going to use it to generate data. Okay, so first thing I'm going to do is what we're going to do is we're going to do a plot. In fact, you can see it on the right-hand side. We're going to do a plot that resembles that. So I need to generate some X data. And the way to do that is to use the arange function in NumPy. And I'm just going to ask it to generate numbers between 1 and 10 or 0 and 10. Let me just run this to show you what it looks like. So I've just ran that. If I ask for the value X, I get 0 to, it's actually 0 to 9, okay? So these are my X points. And now what's nice about NumPy is I can do vector operations. So I can actually do, compute Y, which is a function of X squared. And because X is an array, it'll produce an array Y where each element is X to the power of 2. So let me run that. Let me show you what the Y looks like. So that's the Y, and you can see its squared values all the way up to 81. Okay, so we got the data. Now we're going to do some plotting. So to do that, I'll type the PLT package name, then I'll just type plot. And plot will take just the X and Y vectors. And if I do that, you see this is what I had shown before. So this is a plot of Y versus X. So I want to do a couple of things here. First of all, I want to be able to change the color. So it's really easy to change colors. After your XY pair, you can just specify the color. There's some shorthand ones. I'll show you the codes in a minute, but R stands for red, for example. If I run that, I get red, okay? Now let me show you, here we go. So all I did was I just did a search on, there we go. Oops. The search on matplotlib colors, and I got this page. And these are so-called base colors. So this is the one I just used. It was red, R, so you got blue, green, red, cyan, magenta, and yellow. And you also got black and white, okay? Now, if you want a lot more colors, you have all these name colors here. So let's pick one of these. Let's pick orange red, okay? So I'll take that. Let me just copy, but I won't let me copy paste. So orange red, so I move over there. And I'll just put orange red in here instead. Orange red. Okay, and then I'll run that. Yeah, the color did change, but perhaps not enough to see. Let me put light green in. Maybe that's better. Light green. Do light green. And there you can see green. Not a very nice green, but there you go. So that's a pretty easy way of changing colors. So I'll put back to red. The other thing, though, you might not want a line. For example, you're plotting some experimental data, and you actually need the points. That's pretty easy as well. You don't have to, all you have to do is put the marker type you want after the color. So I'll have a little O, which stands for circular markers. So if I run that, I get my circular markers, okay, also in red. And let me bring this page over again. You can look for markers as well. and there's a whole bunch of different markers, okay? And these are the codes you could use, and this is the marker you get just for fun. Let's do the 1, which is some funny little try down thing, looks like an antibody. Let's do 1, see what happens. And we'll change it to blue instead. And then 1 being the marker. If I run that, you get that funny little marker symbol, okay? Now, the other thing that you'll invariably want to do is to add a legend to your plot. So to do that, you actually need to add a label to your plot. So we might add x squared, okay? So that's the label. Now, if you run this, nothing will happen, actually. That's because you run it again. That's because you actually have to tell it to display the legend. The way you do that is you just go plt legend. And now you can see the legend appears. And I believe it will try to position the legend in a place that is convenient and doesn't overlay the plot. Now, let's say if you wanted to do more than one plot, right? Let's say we did another one. Let's call this y1, then we'll call this y2. Let's create sorry, well, y1. Let's create a y2, shall we? So we'll do let's say x squared plus 3. All right, and then all I'll do then is put another plot in. And that can be x2, and then this one is x squared plus 3. Okay, and I'll just distinguish them as well. Let's make the second one in red. Okay, so if I run this, now you see, yes, they're not very different. Let's try making it a bit more different. There you go. So I have 2 plots now overlaying one on the other with 2 legends. Now, ideally, what you should do also is you should tell it to show, because let's say you wanted to do another set of plots afterwards, but on a new plot, if you don't call show, it'll keep overlaying the plots onto the existing one. So this is sort of a way of finishing off your plot. Now, the other thing you want to do is, you know, if you're publishing, if you're publishing graphs for a paper or report or something, you might want it in a high resolution format. What you can do is you can save the entire thing as a PDF. So to save it as a PDF, you'll just use plt save figure, and then just give the name of the file, and just make sure you put PDF at the end. And I'm not going to show you the PDF, but it's actually generated a file called lineplot PDF. I can tell you where it went. It went to my Dropbox, actually. Okay. So, but you can specify the full path here, and you can get you can deposit that file anywhere you want. Okay, so I think that's basic introduction there to matplotlib. Now, the next thing I want to do is what happens if you're doing a model. Okay, so what I'm going to do is I'm going to get rid of all this here, and we're going to go back to this model. So this is the model we had before, A to B, B to C. And let me run a simulation of it. Simulate 0, 10, 100. Okay, so that's going from time 0 to time 10 with 100 points. And I want to plot this. Now, normally you do r.plot, but in this case, let's use matplotlib. Now, you may be wondering, well, what's my x and what's my y, and how do I get those x and y's? If we don't have the, let me just comment that out. Let me run this, and we'll have a look at M. Okay, so M has 4 columns: time, concentration of A, concentration of B, concentration of C. Now, the fact that these columns are labeled means it's actually very convenient to specify what's X and what is Y. All I have to do is type down the variable, and then in square brackets, put the name of the column. So my X column is going to be time, and my Y column will make that A. And don't forget the square brackets, because that's the name of the column. So if I run this, I get my A versus A, or my A versus time, sorry. I can keep adding plots like this. I can go B and C, let's do that. I get all of them. Let's run it for a bit longer, shall we? Make it look better. There you go. Okay, so that looks better. And each of these you can assign a color, but perhaps of more interest is you can give it each a label. Okay, and you might want to give something A concentration. All right, and then this one you might want to give I don't know, something else. I'll just give it B concentration. Okay, so make it a capital B. But you can put whatever you like here, actually. Oh, let's just do something different. Those of you know LaTeX, you can actually put some LaTeX here. So I'll put, x squared. Not that it makes any sense, but let me put that in there. So to put in LaTeX, you put dollar and then the LaTeX text and then the dollar again. So if I run that, oh, doesn't show. What have I done wrong? What have I forgotten? I've forgotten to tell it to actually display the legend. So if I do that, oops, sorry, mistake, PLT. And now you can see the legend comes up and you can see it's A conc, B conc, and then you can see C A squared. Okay. So that makes it very easy. Now, if you really want, a particular color, you can, of course, add the color to that, just like we did before. Now that's red. And if you really want, I don't recommend it, you want actually the markers as well, it'll give you all the markers too. But we have a lot of markers, so probably don't want to do that. Okay. And again, you can save it. You can save this figure to a PDF file, and ideally you should have plot show at the end to terminate the plot. Okay. All right. So that's that little brief introduction to matplotlib.